Hello everyone. So welcome back to the second video on special series tough questions. So in the previous video we have gone through like couple of questions, and before that we revised couple of formulas. So I'm gonna take you back to that screen. So these were the three formulas that were discussed, and apart from that we discussed like three or four different types of questions. They were basically of the same genre, it's just that the questions were put up in a different way. And now in this video we'll be continuing from there itself. So if you haven't watched the first video, so I would request you to go and watch the first video. However, there is no connection between this one and the last one because the topic is special series, and to be very frank, every question is different question, every question is unique in the way it is put up, in the way it is formed, and especially in the way it is solved. Okay, so it doesn't really matter. All right, let's see what we have. Okay, next question is you need to find the sum for the expression 2 square 2 into 3 square plus 3 into 4 square plus 4 into 5 square and so on and so forth 10 into 11 square. You need to find the sum for these numbers. Okay, so go ahead, try the question, and please do not make use of calculators because in this case I have given it up to only like 11 square. I may give it to like 101 square and 1001 square also, right? So try this question, pause the video. All right, let's see what we can do with this one. So how can I solve this one? How can I deduce a pattern which is gonna help me in solving the questions? All right, so I have I have 1 into 2 square, because 1 into 2 square is nothing but 2 square, plus 2 into 3 square plus 3 into 4 square plus 4 into 5 square and so on and so forth up to 10 into 11 square. So this is more or less like I'm doing n minus 1 into n square, or I can put it in a different way. I can write this as n into n plus 1 square, or you can write this as n minus 1 into n square. In this case n is gonna start from 1, and in this case n is gonna start from 2. It's your call which way you want to write it. It's completely your call. Now let's understand the difference in both the ways. See, these kind of evaluations, you require these kind of evaluations in order to solve a question. Okay, so if you have n into n plus 1 square, this will become n into n square plus 2n plus 1, and multiplying this by n, this will become n cube plus 2n square plus n. So you have a cube term, you have a square term, and you have a n. If I do it the other way, that is n is starting from 2 and it's n minus 1 into n square. So n minus 1 into n square is nothing but n cube minus n square. Which one is better? Second one is better. Okay, so these expressions can be rewritten as 2 cube minus 2 square plus 3 cube minus 3 square plus 4 cube minus 4 square and so on and so forth up to 11 cube minus 11 square. Okay, so you can write this as summation from 2 cube to 11 cube and subtract from 2 square up to 11 square. And in this case, you can simply use the formula for the sum of first 10 squares. So for the cube part, the formula was n into 2n plus 1 into n plus 1 by 6. So this will become 11 into 12 into 23 divided by 6. Now this formula that I have used here, which is n into 2n plus 1 into n plus 1 by 6, that's for the first n terms. That is for the cube of sum of the cubes of first n terms. That is, if I'm going from 1 cube up to 11 cube, then I can use this formula. But what I have is from 2 cube to 11 cube. So what I'm going to do is I'm going to use this formula and I'm going to subtract 1 cube from it in order to balance it. Okay. The formula is from 1 cube to 11 cube. I don't have 1 cube. I'm starting with 2 cube. So I'm going to subtract 1 cube in order to balance out my equation. And same thing I'm going to do with this square part also. So, okay, I think I've made a silly mistake. I'm really sorry. The formula for the cube part is, I'm really sorry. The formula for the cube part is n into n plus 1 by 2 whole square. So that is 11 into 12 divided by 2 whole square minus 1 cube. Okay, so this is for the cube. I have mistakenly used the formula for squares in the cube. Okay, I'm really sorry for that. And I'm going to subtract the formula for the squares. So that is 11 into 12 into 23 divided by 6 minus 1 square. Okay, this is what I need to do in this question. Okay, so cancel this will become 6. So this is like 66 square minus 1, and this will become like 2. So that is 22 into 23. So I need to do that on a calculator. So 22 into 23, that is like 506 minus 1. So this is now minus 1 and this minus 1 is going to get cancelled because there is a negative sign in between. So I am basically left with 66 square minus 506. So 66 square is 4356 and minus 506. So 4356 minus 506. So that is 3850, and that's your answer. Okay. So again, the point that I'm trying to make here is that you need to reduce that part. Only then you'll be able to solve a question. Alright. Let's move on. Let's see another type of a question. Let me give you a question first, then I can remove off the things which are on my board. So the question is A1, the first term of a series is given to you as 6. I'm not giving you the entire statement because first I want you to understand the concept, and then like once you have the entire statement you can solve it. That's not a problem. First term is 6, second term is 4, and the nth term of a series is nothing but an minus 1 minus an minus 2, where n is greater than or equal to 3. Okay, so you need to find the sum of first 100 terms. First term is 6, second term is 4. Any term greater than or equal to 3 can be represented as an minus 1 minus an minus 2. You need to find the sum of first 100 terms. Okay, so try this question. In the meantime, I'm gonna rub off whatever is extra on my board. Alright, let's draw this question now. So first we need to deduce what this means. See, again a different type of a question, but trust me on this part, each of these questions are gonna follow a pattern, a series, and the terms are gonna get cancelled out. These are the only two things that happen in a special series question. There is no third thing that's gonna happen. Okay, there's going to be a pattern, the terms are gonna get cancelled out, and that's it. So this basically here, that is an is equal to a sub n minus 1 minus a sub n minus 2 for n greater than 3. So if I start with a of 3, a of 3 basically means a of 2 minus a of 1, which is nothing but 4 minus 6, which is equal to minus 2. Similarly, a4 is nothing but a of 3 minus a of 2, which is equal to 2 minus 4. 4 minus 6 is minus, this is minus 2. Okay, this is minus 2 minus 4, which is equal to minus 6. Then a of 5 is equal to a of 4 minus a of 3. So that is minus 6. What is a of 3? Minus 2. So minus of minus 2, which is equal to minus 4. So I hope you must have realized the pattern by now. So I'm going to like write the terms now rather than writing them the entire formula and everything. So I'm starting with 6, then I'm getting 4, then I'm getting minus 2, then I'm getting minus 6, then I'm getting minus 4. Now the next term is minus 4 minus of minus 6, which is equal to 2. The next is 2 minus of minus 4, which is equal to 6. Next is 6 minus of 2, which is equal to 4. Now as soon as I get 6 and 2, as soon as I get 6 and 4, you need to realize at this point of time that series is going to repeat itself. You need to have this realization. Let me put it this way, you need to have that presence of mind while you're solving questions like these. You need to realize this point at this point of time, that my series is going to repeat itself. So I have this series which consists of 6 terms, and these 6 terms are going to repeat itself. So my first 6 terms are 6 4 minus 2 minus 6 minus 4 2. Next 6 are 6 4 minus 2 minus 6 minus 4 minus 2, and so on and so forth. And interestingly, the sum of these 6 terms is equal to 0. That means sum for first 6 term is 0, next 6 0, next 6 0, next 6 0, and so on and so forth. So what you're going to do is you're going to divide 100 by 6. So when you're going to divide 100 by 6, you're going to get quotient of 16 and you're going to get remainder of 4. That means quotient 16 means you're going to have 16 complete series of 6 terms each. You're going to have 16 complete series of 6 terms each. So this will add up to 0. Right? This will add up to 0. So basically you will be left with the first 4 term of 17 series. You will be left with the first 4 terms of 17 series. Now first 4 term of any series are equal. So whether it's 17th, whether it's first, whether it's second, it doesn't really matter. So what are the first 4 terms? These are my first 4 terms. Add them up. 6 plus 4 minus 2 minus 6. These two are going to get cancelled and your answer is simply 2. Okay. Now, okay, do me a favor. Instead of taking 6 and 4, take any two numbers and use this principle again. Take any two numbers, 1000, 10,000, whatever two numbers you want to take. Just replace these two numbers and use the same formula and tell me, do you see a pattern in this question or no? You'll realize what I'm trying to say. Okay, take any two numbers apart from 6 and 4, use the same formula, calculate this, or let me put it this way, the equation is exactly the same. You're simply changing the value of a1 and a2. Take any value that you want to take. Okay, and try this question, then let me know in the comment box what do you think. All right, so in the meantime, let me give you another question. Okay, question is find the sum of okay, find the sum of 5 plus 55 plus 555 plus 5555. Okay, many students have asked me, sir, we have difficulties in questions like these, so I thought I'll take up this question. So give this one a try, whatever you can do. Pause the video, give this one a try, then we'll discuss it. This is again like there is a specific pattern and you need to know that very frankly, otherwise you won't be able to solve this question. But anyways, pause the question, try the question yourself first. Alright, let's see what we can do with this one. So I have 5 plus 55 plus 555 and so on and so forth. So I need to find sum for this. So how can I do that? One thing is I can take 5 common and then this will turn out to be 1 plus 11 plus 111 plus 1111 and so on and so forth. Now I don't have any formula to add 1 plus 11 plus 111 plus 1111 and so on and so forth. That's not possible. And neither this forms AP, neither this forms GP, like nothing's happening here. So what you're supposed to do in question like these is that once you take this number 5 common, if in case you have 6 plus 66 plus 666, in that case take 6 common. If you have 7 plus 77 and so on and so forth, then take 7 common and so on and so forth. Then the next thing you're going to do is you're going to multiply and divide by 9. Okay, if you're going to multiply and divide by 9, this will become 5 by 9. 9 plus 99 plus 999 plus 9999 and so on and so forth. Okay, now this 9 can be written as 10 minus 1. This 99 can be written as 10 square minus 1. This 999 can be written as 10 cube minus 1. This 4 times 9 can be written as 10 to the power 4 minus 1 and so on and so forth. So the point here is that your entire expression can be written as 5 by 9 into 10 minus 1 plus 10 square minus 1 plus 10 cube minus 1 and so on and so forth up to 10 to the power n minus 1. If you basically have n terms. So every question that you see of this kind, whether it's 5 plus 55 plus 550, 555, then 4 times 5, or if you have 7 plus 77 plus 777 plus 7777 and so on and so forth, every term has to be written in this form only, that you're going to take that term common and then you're going to multiply and divide by 9. So this will basically become 5 by 9, 10 plus 10 square plus 10 cube and so on and so forth up to 10 to the power n, then minus 1 plus 1 and so on and so forth up to n times. Now if you have 1 n times, then this will basically become n. If you're going to have 1 n times, this will basically become n, and this that you see here, this is basically like geometric progression. Okay, so this is your first term is 10 and your common ratio is also 10. So how do you calculate sum in that case? Your sum is equal to a 10 to the power n minus 1, or that is r to the power n minus 1 divided by r minus 1. And then we're going to subtract n from this. So let me remove this part from here. So this will basically become 5 by 9. Sum for this 10 plus 10 square up to 10 to the power n will become 10 into 10 to the power n minus 1 divided by 10 minus 1, and this 1 n times you're gonna like simply subtract it. So you can write this as 5 by 9, and you'll be multiplying 10 into 10 to the power n minus 1 divided by 9 minus n, and this is your final answer to this question. You can like simplify this further. You can take 9 to be the LCM inside the bracket, then you can multiply 2 9s, that will become 81. But however, the point is, this is the catch in this question, that you have to multiply and divide by 9, then only you will be able to solve questions like these. Otherwise it won't be possible for you to solve questions like these. All right, so let's move on to the next type of a question. Let's solve an easy question this time. So the question is, we need to find the thousandth digit of 9 plus 99 plus 999 plus 9999, like up to 10 terms. Right? You need to find the thousand digit of 9 plus 99 plus 999 plus 9999 up to like 10 terms. Basically means like the last term will basically become 9 10 times. Okay, so you need to add all these terms and you need to tell me the thousand digit of that sum. Correct. So pause the video, try this question yourself. This is typically a easy question in comparison to what we have been doing in the past two videos. Okay, so pause the video and try this question yourself. All right, let's see what we can do with this one. So if I'm gonna add them up, it's gonna look something like this. You're gonna have like 9 9 10 times, then you're gonna have like 9 9 times, then you're gonna have like 9 8 times. So this is like 10 times 9, there's like 9 times 9, and so on and so forth. You're gonna have the second last term as 99 and the last as 9. Now observe carefully, you'll realize that if you talk about the unit digit, you basically have 9 10 times. You basically have 9 10 times. If you're gonna add them up, it's gonna be simply 9 into 10, which is equal to 90. When you go to the tens place, you're gonna have like 9 9 times. You're gonna have 9 9 times. Now when you added all the 9s at the unit place, you got a sum of 90. you're gonna keep 0 and 9 will be carried over. Okay, so you're gonna keep 0 here and 9 will be carried over. So I have 9 times in the 10 in the tens place. Apart from that, I have one more 9 which is carried over. So again I have like 10 nines. So 10 nines is gonna give me again 90. It's gonna give me again 90. So 0 again and 9 will be carried over again. Alright. Now when you come to the hundreds place, in hundreds place you're gonna have like 8 nines. You're gonna have like 8 nines. So 8 into 9 is 72, and one more 9 of the carried over. So 72 plus 9 will become 81. So you're gonna have 1 here and then 8 will be carried over. Alright. Now when you come to the thousandth place, you're gonna have like 7 nines. 7 into 9 is 63, and 63 plus 8 is 71. You're gonna have 1 again and you're gonna carry over 7. So this is the units place, that is 0. Then you have the tens place, that is 0. Then you have the hundreds place, that is 1. And then you have the thousands place, which again has 1. So what is the thousands digit? Actually, there has to be an S here. So what is the thousands digit? Thousands digit is 1. So this is basically the concept. It's not a difficult question, it's just the way it has been put up. That's what you need to understand. So you basically have 9 10 times, so 90, then 9 will be carried over. Then you're gonna have 9 times, that's 81. Add 9 from the carryover, that will again become 90. Then put 0, 9 is again carried over. You're gonna have 9 8 times, so that is 72 plus the 9 of carried over, that's 81. Keep 1, 8 is carried over, and the process continues. Alright. So typically easy question. Alright. So let's do one thing. Let's keep it till here for this video. We have already done like couple of questions in this one, and I'll be making like one more video on this special series tough questions. So we'll be picking up like couple of more questions so that your understanding becomes crystal clear on this topic. Alright guys, thank you so much for watching the video. Keep watching and keep learning. If you have any concerns, any doubts, any questions, do let me know in the comment box. Thank you so much for your time.